Hello everyone, thanks for tuning in to the 11th Winter 2017-18 update from GazWeathers.com. So we've done 10 updates so far, started the updates on the first Sunday of September, and we said we're going to carry on running the updates through to the end of November, and then on Sunday, the 3rd of December, we'll be issuing the GazWeathers.com Winter 2017-18 forecast. So, we have reached the penultimate winter update. Once this one is done and in the can, there will only be one more update to go. The 12th and final update will be next Sunday, and then after that, 2 weeks today, we will release the GazWeathers.com Winter 2017-18 forecast. So, we're nearly there now. We're coming towards the end of the journey, and what a journey it's been. I think these have been the most extensive, exhaustive, and biggest researched sort of winter updates that we've done so far at GazWeathers. It's been an epic season of updates. And we're drawing to a close with them now, but we've still got this update and the next update to go, and this update, as well as all of the regular stuff that we always look at, such as sea surface temperature anomalies, ENSO, that kind of thing. We will also have a solar special, because I felt we hadn't really touched on solar activity all that much for this season. So this 11th update, if you're interested in the solar stuff, then this will be a bit of a solar updates special. I'll talk you through all about that when we get to that point in the video. Before I get on with that, though, just to say that later on today, we're going to have a video looking at the long-range season models from the ECMWF and Meteo France season models for the winter. Those models have always been restricted up until very recently. Now they are online, and you can see them, and you'll be able to do that in this afternoon's video. It'll be around 2 o'clock. I'm giving it its own specific page here at website, brand new page, that you'll be able to find the link to from here on the homepage, and also from my Twitter feed and all that kind of thing. Of course, a video will be available on YouTube as well. So that'll be coming up around 2 o'clock this afternoon. You'll see what the ECMWF and Meteo France long-range season models think about this winter. And then, of course, this video is going to be quite a long one. They always are, these winter updates, so if you can't watch the video all in one go, don't worry, you will be able to come back to the website and watch it whenever you want, because this evening, this 11th Winter 2017-18 update will be placed on the Winter Updates page. There'll be an extensive written report that goes with it as well, so you'll be able to come back and see the video whenever you would like to do that and read the written report. I usually get video placed on Winter Updates page sometime around 7 o'clock in the evening, something like that. So, can't watch it all in one go. You will be able to come back and see it whenever you want. And what else I'm going to say? So I'm going to say that the Chris shop is open. So we've got a Chris shop to do at Amazon between now and Chris. We have to click green button that says Gaz Chris Shop. It takes you through to our Chris Shop page, and then from there, the key to it all is to go through the Amazon banners, because you're going from GazWeathers to Amazon from the Christmas Shop page. It means that we get a revenue fee on the things that you're purchasing and things that you're buying. A big, big thank you to everybody for doing that again for GazWeathers. Right, I think that's everything discussed, so let's get on with the Winter 2017-18 update. We're going to begin this update by having a look at the oceans. So this is the latest, or this was last week's sea surface temperature anomaly map, when we did the 10th Winter 2017-18 update. The three areas that we're interested in specifically are, of course, the ENSO region, which is over here. We're interested in the Northern Pacific Ocean. We're interested in the Atlantic Ocean. And this year, particularly, we're also interested in that area there, which is the Norwegian Sea. So that's how the sea surface temperature anomalies were looking last week when we did the 10th Winter 2017-18 update. A strengthening signature of La Nina, the cold event through the actual Pacific Ocean, was really the main talking point. Let's have a look at the very latest, and this is it. This is from the 16th of November from NOAA. So let's deal with the ENSO region first of all, that being the ENSO region just there. Let's go back and have a look how things were shaping up last week. So that's last week in the ENSO region, from Peru to Indonesia through the Equatorial Pacific Ocean. This is the latest. Now, very little change. I don't think we're seeing any further strengthening through the week of the cold signature. But we haven't seen weakening either. It's just basically now is a static weak landing event, weak cold event that we have here across the Equatorial Pacific. Almost, I would suggest, going to borderline strong, borderline moderate landing event. So it's kind of like weak landing into borderline moderate. Whether it ever gets designated, and we talked about why it may not actually get officially recognised. It has been designated by NOAA. They've said that we are going to have a landing winter for winter 2017-18, but whether it's actually officially recognised in the archives, it may not be, because it might not run to the full criteria, which is to go below, at or below minus 0.5 degrees below average over 5 tri-monthly periods. It might not do that because it's such a late starter. But if it doesn't make any difference to the fact that this will be a landing winter. The signal is strong enough that this is going to be a landing winter, and the impacts of what that could mean were discussed right at the very start of the videos. Actually, it's one of the places that we started at this season. Let's go and have a look at the Northern Pacific. So that's how things were looking in the northern part of the Pacific Ocean last week. What about the situation now? Again, very little change, possibly a little bit cooler up here in this northeastern part of the Pacific Ocean. Perhaps a slight cooling may have taken place up there over the past week. But again, no real changes happening in the Northern Pacific, and not really much sign of change in the Northern Atlantic either. So again, this situation last week in the Northern Atlantic Ocean around here. Let's have a look at the latest for this week. And again, very little change has taken place, looking broadly similar in both the Northern Atlantic and the Northern Pacific Oceans. We still have that very warm sea surface temperature anomaly up around the Norwegian Sea. It has cooled down a bit since October. It was getting very close to record levels, I think, in October. It has cooled down from there, but it is still a broad, warmer than average anomaly that we have there in the Norwegian Sea in terms of sea surface temperature anomaly up there. Right now, I had some news from one of the people who comment at Gazwovids about this, what this could mean. Because if you've been watching videos, you know I've been very uncertain about what this warmer than average sea surface temperature anomaly in the Norwegian Sea could mean, because it's such an odd place to have such an extensive warm anomaly. Johan, who posts, I think he posts from Sweden, has posted in the comment box over the past few days at Gazwovids to say that the Danish Met Office agency have issued their winter forecast. In Denmark, they are going for their coldest winter for 4 years. So the coldest winter in Denmark is being predicted back to 2012, 2013. But interestingly, Johan says as part of that forecast, the Danish Met Office have said that one of the things that might offset a cold winter is warmer than average sea surface temperature anomalies in the Baltic Sea being over there, of course, and also over here on this map. But also they cite warmer than average sea surface temperature anomalies generally to the north, which is sort of this area, I suppose, around Barents Sea perhaps, and over here in the Norwegian Sea, and also the Kara Sea, and there are various other seas as well in this area. I ran into trouble with that a little bit in the earlier updates. But anyway, the Danish Met Office are saying that they think they're going to have the coldest winter for 4 years in Denmark, but one of the things that could offset the chance of a cold winter is the warmer than average sea surface temperature anomalies both in the Baltic and to the north of Scandinavia. So I think we have to assume then, therefore, that this warmer than average sea surface temperature anomaly that we have here in the Norwegian Sea, if it perseveres into winter, it's certainly going to persevere into the start of winter. We can't say if it'll still be there by January and February, but certainly it'll still be there next month. And it is, I think we can assume, a bit of a signal for a warmer, milder winter. But there are other things that are offsetting that, and that's why the Danish Met Office think that actually in Denmark they're going to have the coldest winter for 4 years. In terms of what's happening in the Atlantic, so we do have a warm Atlantic Ocean, North Atlantic Ocean. At the moment, it is generally in a warmer than average state. Turning a little bit cooler to the south of Greenland. We don't have a tripod. I've explained this before. To get a negative NAO, we want the three-way band of warm, cool, and warm. We certainly don't have that. We just have a generally warm Atlantic Ocean. So the Atlantic is not particularly well set up for a negative NAO this winter, but it doesn't mean that we can't get a negative NAO at some point through the season. And then we have a look at a little bit more on the ENSO regions. So I haven't looked at these for a little while. These are subsurface temperature anomalies from NOAA's ENSO PDF. This is fascinating. Really, it has loads and loads and loads of information. Within this, it's updated every week. So you can find a link to it on the links page. Do check it out. So what you're seeing here is the subsurface temperature anomalies. These temperature anomalies just here are sort of sea surface temperature anomalies, but these ones are subsurface temperature anomalies, what the ocean temperature is doing at depth. So this is like the surface of the equatorial Pacific Ocean just here. That's the sea surface. And then we go further and further down, sort of 200, 250, 300 meters, going further and further down into the depths of the Pacific Ocean. So this blue area is all the cold subsurface temperature anomalies that we have at depth in the equatorial Pacific Ocean. Quite clearly, we can say that this La Nina, this cold event signal, is being enforced by what's happening at depth. It's not just a little bit of colder than average sea surface temperature anomalies right on the surface, but there's nothing to it underneath the surface of the Pacific Ocean. Actually, the cold subsurface temperature anomalies go to quite a long way down, and they are quite intense as well, with the anomaly at its core going down to around 4 to 6 degrees below average. So quite a strong La Nina signature at depth. We do have some warming beginning to occur around here at depth underneath the surface of the Pacific Ocean, right over in the western part of the equatorial Pacific. Whether that will eventually sort of displace all of these cold subsurface temperature anomalies, I'm not sure. Whether this is kind of like the beginning, perhaps, of swinging towards El Nino next year, again, I'm not sure about that either. But certainly for this winter, and that's what we're interested in, of course, what's going to happen for this winter, we can say it is going to be a La Nina winter, even if it's not officially recognised in the archives. Just have a look at some forecasts. So they're all in now. This is CFS-V2, region 3.4. Forecast for the ENSO region. The black line here is where we are right now. We've got the dates on the bottom, temperature on the side. That's where we are right now. We are in La Nina condition now, albeit weak La Nina. By the end of the year, into the start of 2018, we're going there with the black dash line. So again, that's keeping us in La Nina condition through the early part of 2018. It's not really until we get through to the spring where we start to go back up towards neutral. So if that's right, we will get this La Nina designated, because there's certainly 5 tri-monthly periods there where we're going underneath 0.5 degrees below average. This is the ECMWF. ECM is forecasting again a sort of weak La Nina event. So this is where we are right now with the ensemble plume. Where we'll be by end of the year, again, dates on the side, anomalies on the side, I should say, dates on the bottom. Where we are forecast to be by the end of the year inside 2018 is around here, so going down to around -1 as the anomaly. That is again in La Nina condition, albeit weak La Nina. And then Jams Tech IOD. So again, Jams Tech has us in La Nina condition. We are there right now, actually around there right now, and the forecast is to keep us under -0.5 degrees below average through to around March, April time. So again, in a weak La Nina for the winter of 2017-18. Do keep in mind that is a huge change on where we was expected to be, where these models were forecasting us to be at the earlier part of the year. So back into the summer, it was actually being predicted to have an El Nino, can you believe? To have a very quick look at Siberian snow cover. So this situation last week when we did the 10th update in terms of Scandinavian, Russian / Siberian snow cover, we had lost a bit of snow actually when we did last week's update compared to where we've been in the updates before. We've lost a little bit across Scandinavia, and we pushed the snow line back a little bit, back away from Western Russia. This is the latest when we're doing the video right now for the 11th Winter 2017-18 update. You see we have gained a bit, so we've pushed that snow line back towards Western Russia. We've also gained snow cover across Scandinavia as well. So again, comparing to that was last week, this is this week. Quite clearly we have gained snow cover, which you expect because we are now going into the middle of November. I'm not sure this has too many impacts now. The main part when we look at this is through October, where there are feedbacks going on with snow cover across Scandinavia and Russia and Siberia through October. But once you get into sort of the late autumn period, I'm not sure there are any feedbacks worth mentioning or worth looking at. What we can say, though, is that the snow line is beginning to advance back in towards the western part of Russia, possibly even into the far east of Europe. This is the 2017 Atlantic Hurricane Season page from Wikipedia. So we'll be looking at this all the way through the season of winter updates. It's been a big hurricane season, it's been a hyperactive season, as they're describing it at Wikipedia on this page. These are all of the hurricanes that we've had through this season. All these lines just here, these current lines, are the various storms and hurricanes and different disturbances that we've had in the tropical Atlantic through this hurricane season. Let's scroll down and have a look at the numbers. So right now we have had 18 total depressions, we've had 17 total storms, we've had 10 hurricanes, and we've had 6 major category 3 or above hurricanes. Those numbers have not changed from last week, so it looks as though the hurricane season is very rapidly winding down now. It kind of shut off very suddenly at the sort of end of October, and we haven't seen much at all through the course of November. It looks like you can never say never, really. Even into December you can get tropical storms occurring, but it looks like, barring something unexpected happening, we're more or less at the end of this big hurricane season now. We had a hurricane special last week for the 10th update, of course, so we know that the effects of this can increase the chance of more blocking in the winter. Again, not a guarantee. There's never ever a guarantee for the UK, particularly in terms of winter weather. So many variables, so many factors come into play. But it does appear that there is a connection between big hurricane seasons and the chance later on into winter of winter blocking. And the feedback mechanism is probably taking warm air out of the tropics via these storms and hurricanes, pushing that warm air, distributing it around the northern hemisphere. Eventually that warm air finishes up in the polar regions, and of course that can translate back later on to an increased risk of blocking in the polar and Arctic area. So that's the connection, and we did examine that when we had a look at the 10th update. So if you'd like to know more about that, go and have a look at last week's video. Right then, the rest of the video is going to be covering solar activity. So this is the solar disk on our side of the disk today from solarham.net. So activity is officially at very low levels, and is forecast at Solarham to be staying at very low levels for the rest of the sort of weekend, certainly start of next start of next week. Next 3 days are being forecast to be at very low levels with solar activity. We have one sunspot region just there, otherwise not a huge amount to be seen. This is the Eleventh Winter Update Solar Activity Tracker from our good friends James Ackrill. This is updated up to yesterday, up to the 18th of November. It's today when I'm doing the recording. So you can see what's going on with solar activity. We are at a very minimum level of activity now. This was the run of the spotless condition that we had on the sun. No sunspots at all for quite a few days, over a week. We have seen a little bit of a tick up with sunspots. You can see just there with that orange line going up. The orange line on this chart is showing you all of the everyday sunspot activity going right way back into the start of the year, actually back to January over there. So yes, we have seen a few sunspots over the past few days after that run of spotless condition on the solar disk, on our side of the disk. But essentially, we are at a very minimum level of solar activity. Those little tick up in sunspots was enough to level off the decline in the trend line. So the red line here and the green line, they are our trend lines, and you can see that they've very much been trending down really quickly, actually, from the spike that occurred way the trend lines lifted up through the early part of the update. Seems a very long time ago now, but back at the start of September we did have quite a big spike in solar activity. Since then, through the season of winter updates, the tracker has been moving downwards all the way along. That movement downwards has been sort of levelled off a little bit. It hasn't been stopped. It has been levelled off a little bit. See that by the thick green and thick red lines, by this slight uptick in sunspot numbers that have occurred in the past few days. But essentially we are at a very, very low level of solar activity now. So this is the solar cycle 24 from beginning to where we are right now. So this is tracking every month's sunspot activity for this solar cycle number 24, going back to the very beginning of it, back in 2008 over here, to where we are right now over here. So you can see that it's a very, very slow climb out of solar minimum through the early part of this cycle, 2008, 2009, 2010, into 2011 even. A very, 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 very slow climb out of that long solar minimum that occurred from solar cycle 23, solar cycle 24. We had our first peak of this solar cycle just there, very weak peak, but it did occur in 2011, at the end of 2011. Then the solar activity declined through 2012 and into the first half of 2013 before lifting up, and at the start of 2014 then we go into our second peak of the solar cycle 24, and that was the bigger of the two peaks. So the maximum occurred in at the start of 2014 in February, I think, 2014, since which we've been moving downwards, back down into a minimum level of solar activity. It's not a linear process, you'll see. So we have a spike up just there, and then a drop, and then we have a spike, and then a drop, and then a spike up, and then a drop, and then another spike, and a drop, and so on, until we reach where we are now. Where we are right now, this is the spike that occurred in sunspot numbers back in September. So that was really quite significant. It took us back to a level we haven't been at really since, let's say, sort of mid to late 2016. So quite a significant spike in activity in September. But that's where we are right now, or where we was for October. So from September to October, we saw a real crash in sunspot numbers, and that's as low as we have been with sunspots over a monthly period. That's as low as we've been since going right the way back over here. We go right the way back, I think, to kind of like early to mid 2010. That is the level we are at now with sunspot numbers. Of course, in the next few months, we're going to go down to that sort of level when we reach true solar minimum in around 18 months or so's time. So we're back where we was around 2010 in terms of monthly sunspot numbers. Now, 2010 was a very cold year. It had the cold winter of 09-10. It had the December to remember in 2010. And you might think that because solar activity has gone back to where it was in 2010, that sort of is a guarantee of a cold winter. But the problem with that idea is that back in 2010, we was coming out of the solar minimum, trying to rise up into the main part of solar cycle number 24, and really struggling to do so. So that period was coming out of the solar minimum. This period is coming out of solar maximum and going into solar minimum. So they're two different things. Although the overall numbers are the same, actually the effects that we might expect from this are a little bit different. So it's not as guaranteed at this point in the solar cycle that you get a cold winter, excuse me, again, compared to more, it's never a guarantee with weather, but there's a greater chance that this sort of level of activity coming out of solar minimum will increase your chance of a cold winter compared to this sort of level going out of solar maximum and going into solar minimum. Now, this is solar cycle 24 compared to all other solar cycles back to number 1. So the red line here is solar cycle number 24. It just highlights again how weak this solar cycle has been compared to most of the solar cycles. Solar maximums are occurring up there, way above the solar maximum solar cycle number 24. That's where we are right now as well compared to all other solar cycles. And you can see we are at a very minimum level of sunspots and solar activity. Look how much lower we are compared to virtually all of the solar cycles back to number 1. We have really seen a very weak solar cycle, and the decline from solar maximum towards solar minimum is also very weak as well. So it's not like we've done something like that and had a weak maximum, but then we've kind of converged with most of the solar cycles as we come out of solar maximum and headed towards solar minimum. We haven't done that. We have stayed all the way along from the beginning just there through to the solar maximum just there, and now to coming up towards the end of the solar cycle, all the way along we have stayed at a very minimum level of activity. And this is at the moment, compared to all of these other solar cycles, it appears to be virtually the weakest solar cycle there is back to number 1. If it's not the weakest, it's certainly among the very weakest solar cycles at this point compared to all those other solar cycles. So that's really interesting. And then of course we've got the weaker end of the solar cycles, which are solar cycles number 5, number 6, number 12, number 14, number 16, and our cycle number 24. These are the weakest of the solar cycles, so you can see again very much on a par with solar cycle number 24 to that pink solar cycle number 12, both in terms of how we came out of the solar minimum preceding the solar cycle, how we went into the solar maximum, the double peak solar maximum, and then how we dropped out of solar maximum and headed towards solar minimum. You can see very much on a par with solar cycle number 12, but also in there with number 16 as well. We've been running quite closely in terms of coming out of solar maximum anyway with solar cycle number 16. These two just here, very weak solar maximums. Those are the delta minimum solar cycles of number 5 and number 6 as well. Where we are right now compared to these solar cycles, these weak solar cycles, is just there. So you can see the trend now is really going to be down into solar minimum occurring around here. We haven't got all that much longer to go now before we are at true solar minimum. Just say these charts have all been sent through, updated and sent through to me by James Ackrell, so thanks so much to James for all of the input with this video in particular, but also with the winter updates that we've done through this season. Everything that you see from this point on actually is going to be James's work, really. So really easy week for me. I've not had to do too much, just presented all. So this is comparing solar cycle number 24, the current solar cycle, to solar cycle number 12. There has been a close connection between these two solar cycles, the way they have developed, so the way we have come out of the solar maximum over here, and the solar maximums of the two solar cycles have been very similar, and the way we went into those solar maximums and came out of the solar minimums of the preceding cycles, all been very, very similar indeed. The two solar cycles 12, which runs from 1877 to 1890, solar cycle 24, which runs from 2008 to current, very similar. This is where we are now compared to solar cycle number 12. Solar cycle number 12, by the way, on these charts, indicated by the green lines, 24 indicated by the orange lines. So that's where we are right now compared to solar cycle 12, and we are very much on a par with the same point in solar cycle 12. Very interestingly, very, very close to this point in solar cycle 12. And you can see what happened with solar cycle 12 was that it just carried on at a very, very minimum level of activity until we reached the true solar minimum of solar cycle 12, which was around this point just here. Haven't got all that much longer to go now before we are at the end of solar cycle 24, and then of course we'll have to start thinking about solar cycle number 25. That's going to be really interesting to see what happens with that. You've seen this before. I just wanted to touch on this a little bit because it goes back to the last video when we had a look at hurricane season. So we know that earlier in the solar cycle there appeared to be a connection between the winters of solar cycle number 12 and solar cycle number 24, the current solar cycle. So for example, the first winter of both of these solar cycles, number 12 and number 24, were milder than average winters, but then the second winters of these two solar cycles were colder than average, as was the third winters of these two solar cycles, and the fourth winters these two solar cycles as well. Then the fifth winter of these two solar cycles was milder than average. We diverged in the sixth winter, which was 1882, 1883 and 2012, 2013, because the winter in the 1800s with solar cycle 12 was milder than average, but the winter in solar cycle 24, which was 2012, 2013, was cold on average. You go back on trend to the next winter, both of them milder than average. The following winter comes out very close to average. Let's say that those are coming out very close to average. But then we get to this winter, which was 1885, 1886 and 2015, 2016, and we get a big split occurring. So in the 1800s winter, in the solar cycle 12 winter, it's significantly colder than average winter, whereas in the solar cycle 24 winter, we have 2015-16, was an exceptionally mild winter, and that split continued into last winter as well. Again, it's the counterpart to 2016-2017, which was a slightly milder than average winter, is 1886-1887. And that one was a colder than average winter as well. So after being seemingly on a trend through most of this solar cycle between the winters of the two solar cycles, the last two winters have split it and diverged. And the interesting point for this coming winter is, will we continue to have a split between two solar cycles, or will we go back to trend because it was a colder than average winter of 1887, 1888. Now, when we looked at last week's hurricane years with big hurricane seasons and the winters that followed them, what we saw was several that were occurring in this solar cycle number 12. So, for example, I'll show you the winters that were occurring following the big hurricane season. So we had 1878, 1879 following the big hurricane season of 1878. That was a severely cold winter, of course, following that very active hurricane season. We also had 1879, 1880, following the hurricane season of 1879, and that one was a cold winter as well, particularly early on, and then it moderated after December 1879, which was another severe month. We have 1885, 1886 as well, so that was another cold winter following the hurricane season of 1880. 85, doing something like that flow and with jet stream. And then we also had 1886, 1887, again another cold winter following the hurricane season, big hurricane season of 1886. So let's go back to the correct chart, which is this one. So it was these 4 winters. It was this one, it was this one, and it was also this one and this one. And you notice all 4 of those were cold winters following those big hurricane seasons. And quite interesting how many years within solar cycle 12 had those big hurricane seasons and cold winters. So I thought I'd just give you a little bit of a look at that as well. Now, the rest of the video is going to be having a look at analogues dealing with winters that are getting close to solar minimum, because we can see quite clearly from this chart, which is showing all solar cycles back to solar cycle number 1, we can see that we are now getting closer and closer to solar minimum. Solar minimum is going to happen there. We've probably got another 2 winters before we reach true solar minimum. So this coming winter, 2017-18, is going to be the second winter before solar minimum. Next winter, which is going to be, of course, 2018-2019, that will be just 1 winter before solar minimum, and then the winter that comes after that will actually be after solar minimum. So we're 2 winters away now from solar minimum. What we're going to do is have a look at how the winters that were 2 years before solar minimum shape up, and we're going to go right way back to solar cycle number 10 first of all. So this is the winter of 1864-1865, which is 2 years before the solar minimum of solar cycle number 10. And this one, it looks like a very unsettled winter. It looks like a cold winter as well, 1864-1865. We have got a bit of a blocking signal around Greenland. And we do something like that with the flow and with the jet stream as well. So it does look as though winter of 1864-1865 was a cold winter 2 years before solar minimum, solar cycle number 10. Then we go through to solar cycle number 11, and we're the winter 2 years before solar minimum of solar cycle number 11 is 1877. This one doesn't look particularly cold. This one looks very unsettled. A strong Atlantic signal with the jet stream coming through the Atlantic into the UK like that. It looks like it's a very cold winter over in eastern parts of America, however. But for us, it looks like it was generally quite a mildish, very wet winter. Then we're moving through, if we can, we're going to go through, let's get rid of that, and we're going to go through to the next winter. This is the winter that's 2 years before solar minimum, solar cycle 12. So this is 1887, 1888, and this is a cold winter. Well, we know that because we're just looking at the information for solar cycle 12 and the winters of solar cycle 12. So this is a cold winter, below average heights to our north, above average heights to our north, I should say, below average heights to our southeast, and pulling in the winds from a northeasterly direction. That was a cold winter there. 2 years before the solar minimum of solar cycle 12. We go through to solar cycle 13. The winter 2 years before the solar minimum of solar cycle 13 was 1899, 1890. This one, I don't think this was a particularly cold winter. It does have a blocking signal, interestingly. We've got a lot of above average heights to our north. But overall, I think actually it's quite a mild winter, this one, 1889, 1890. Next, we have 1911, 1912, 2 years before the solar minimum of solar cycle number 14. This is quite a mild winter. It's a very unsettled and wet winter as well, bringing the flow through like that. We do, again, have a blocking signal around Greenland, quite interestingly. And there was some quite cold weather, especially in early February 1912, but otherwise it's actually quite a wet winter. Next up is 1921, 1922, and this is 2 years before the solar minimum of solar cycle number 15. This one is another unsettled and mild winter overall, very wet winter, unsettled winter as well, doing something like that with the flow and with the jet stream. We're moving on now. We're going up to the winter of 1931, 1932. This is the second winter before solar minimum of solar cycle number 16. And this one is a very anticyclonic winter, a lot of dry weather, really rather different winter compared to any that we've seen so far, with a strong sort of anticyclonic signal going on there. The next winter is 1941, 1942, which is 2 years before the solar minimum of solar cycle number 17. This one is a cold winter. It's another one of those cold 1940s winters with lots of high pressure and blocking to the north and to the northwest of the UK, below average pressure to the south and the southeast. And again, we pull in the winds from the northeast. Another severely cold January in 1942. We're getting closer now to the latest solar cycles. So we're up to solar cycle number 18. This is 2 years before the solar minimum of solar cycle number 18. It's 1951, 1952, and this was quite a coldish winter. We have below average heights to our north and to our east, above average heights to the west, and we do pull the air down a little bit from a northwesterly direction as well. Quite an unsettled and quite a chilly winter, 51, 52. Right, we're seeing this cropping up again. It's been appearing quite a lot through these winter updates. It's 62, 63, the daddy of the cold winters, the coldest winter since 1740, 2 years before the solar minimum of solar cycle 19. We know all about this winter. It's a bitterly cold, severely cold winter, loads of blocking to the north, the low pressure to the south, and those strong easterly winds blasting in across the country. 62, 63 is quite an analogue for 2017-18, because it has been appearing quite a lot. And if you assume this analogues package is more in line with sort of the current position, because I think we are 2 years away from solar minimum. You never really know when solar minimum exactly is going to occur until it's happened. So you don't really know when you're going to get solar minimum until you passed it. But I think we can say with pretty good confidence that we are probably, unless something very unexpected happens, i.e. it's a very unusually short solar cycle, or it's a very unusually long solar cycle, I think we can say we're 2 years before solar minimum, or 2 winters perhaps would be a better way of describing it, before solar minimum. So 62, 63 is definitely an analogue for us for the current position with the solar cycle. Next, we're up to solar cycle number 20, 2 winters before solar minimum of solar cycle 20. It's 73, 74. We haven't seen this year before. This is a very unsettled and pretty mild winter. Many of the winters through the early and mid-1970s were mild, this one included, 73, 74, wet and mild. The next winter, 2 years before solar minimum of solar cycle 21, is 84, 85, 1984, 1985, and this one, it's another cold winter, has a strong signal for having blocking up to the north, to the northeast, with the below average pressure to the south, and we get those winds coming in from an easterly direction in 1984, 1985. We're getting closer now, closer to the current solar cycle. So we're up to solar cycle number 22. This is 2 winters before the minimum of solar cycle number 22. It's 94, 95. This one is mild and wet. So it appears most of these winters, quite interesting, they're either cold, and some of them are really spectacularly cold, such as 62, 63 and 84, 85. They're either cold or they are sort of very wet and zonal type winters. This was another one that was very wet, 94, 95. And then we come up to the last solar cycle, which is solar cycle number 23, 2 winters before the solar minimum of solar cycle 23. It's 2006, 2007. And this one, again, it's another mild winter, and it's quite an unsettled winter for the north, but for the south, it is drier with that area of above average heights. But there was a lot of wet weather through the winter of 2006, 2007 up in the north, and later on, that rain by February 2007 was working its way to the south. And you combine all of those winters together 2 years before solar minimum. Remember, this is kind of like the analogue for this year. Combine all those winters together. This is what you come out with. It's a signal. It is a signal for a cold winter. Again, most of the analogues we've looked at this season, really interesting, most of the analogues we've looked at this season have been signalling a cold winter, and this continues that idea. It is a signal for blocking and the below average heights to the south, and getting the wind in from the east and from the northeast as well. Quite interesting, that, to say the least. But we know it's not a guarantee, because I think whilst most of those winters within that analogues package were sort of signalling cold conditions, if it doesn't go cold, it actually looks like it could be very wet and quite stormy. There are several winters in there that are very wet, quite stormy. Finally, I just want to take you up to the winters that are just 1 year before the solar minimums of these solar cycles. These will probably be more impactful for next year's winter updates, but I just wanted to show you the difference between 2 years before solar minimum and 1 year before solar minimum. So we're going back to solar cycle 10, and we're having a look at the winter of 1865, 1866. This is 1 year before the solar minimum of solar cycle 10. And this one, it's a milder winter. It's a much more active winter. We've got the below average heights to the north and the west. We've got the above average heights to the south and the east. And we bring those mild winds in from the Atlantic. 1 winter before the solar minimum of solar cycle number 11. It's 1877, 1878, and this one is a coldish winter. Not as bad as the next winter, 1878, 1879, but it is a coldish winter. We have the winds coming in from a northerly type direction with that one. Also fairly dryish as well. Then we go through to solar cycle number 12 again. So we're looking at 1888, 1889. 1 winter before the solar minimum of solar cycle number 12. This one has blocking signal out to the west, below average heights to the north and to the south. Looks like it's another cold winter, 1888, 1889. The next solar cycle is solar cycle number 13. 1 winter before the solar minimum of the solar cycle number 13 is 1900, 1901. This looks like it's a stronger signal for a cold winter with quite a blocking signal around Greenland. And then we have, let's change the colour, we have the low pressure into our south and also to our east. Don't know too much about that winter, 1900, 1901. I don't think there was many winters that were cold between 1895 and 1940. Most of the winters through that early part of the 20th century, first 40 years, were generally quite mild, but there were a few colder ones, and maybe 1900, 1901 was one of them. 1 year before the solar minimum of solar cycle number 14, it's 1912, 1913. This one, it's a very wet winter, very mild winter as well, with those westerly winds coming in from off the Atlantic. We're up to solar cycle number 15, so we're up to 1922, 1923. This is another unsettled looking winter. It's very Atlantic driven, and it's a milder winter. So do we think at the moment these winters that are 1 year before solar minimum, there are more mild winters appearing in these analogues compared to winters that are 2 years before solar minimum? That's quite interesting and maybe a little bit unexpected. Let's carry on. So we go through to 1932, 1933, which is one winter before solar minimum of solar cycle number 16. This one, 1932, 1933, is an anticyclonic winter, has a lot of dry weather, low pressure being blocked down there. So it's a slightly different winter in many ways. There's a lot of dry weather, and there is quite cold weather at times as well for the winter of 1932, 1933. We're moving on. We're going up to 1942, 1943. One winter before the solar minimum of solar cycle number 17. And this one, we have the above average heights to the south, below average heights to the north. This is a mild winter. This one cuts off those cold early 1940s winters, and we finally get a milder one for 42, 43. Then we go through to 52, 53, which is one winter before the solar minimum of solar cycle number 18. This one's a rather colder winter, has a blocking signal out to the west with below average heights to the east, and again we do something like that with flowing with jet stream. Quite a stormy winter in 52, 53, quite a bit of coastal flooding, and fairly cold at times as well. 63-64 follows the coldest winter since 1740, and it's almost another cold winter actually, 1 year before the solar minimum of solar cycle number 19. Almost a cold winter, have a strong blocking signal, so it's another dry winter with high pressure generally to the north of the UK, but not as far north as we have it in 62, 63. So this one brings in a lot of dry weather, and there was some cool conditions at times, although it's not remembered as a particularly cold winter in 63, 64, but it's a bit of a near-miss winter in many respects. Then we go through to our next winter, which is 74, 75, 1 year before the solar minimum of solar cycle 20. This is a milder, drier winter. I think in this analogues package, we're definitely seeing milder winters compared to the previous analogues package. This one is bringing the air up from the Atlantic rather like that. We have a southwesterly winds. It's a dry winter despite being an Atlantic winter. It begins the drought of the mid-1970s. Then we're up to 85, 86, which is one winter before the solar minimum of solar cycle number 21. And this one, it's a cold winter, of course. This one has the strong blocking signal up to the north with the below average heights to the south. And we do something like that with the flow and with the jet stream as well. So that one, a cold winter in 1986 with a severely cold February. Then we're up to 95, 96. This one is cropping up a lot in our analogues as well. This is one winter before the solar minimum of solar cycle number 22. And this is a cold winter. It's cropping up so much, you know all about this one, 95, 96. Cold winter with the high pressure to the north, the low pressure to the south, and there's those easterly winds coming in. And then finally, we're up to the final winter of solar cycle number 23, the last solar cycle before the solar minimum of solar cycle 23 is 2007, 2008. And this one is a mild winter. A lot of dry weather as well in this winter to the south and to the east with that ridge. Low pressure is to the northwest of the country, and we're on the mild side of the jet stream through the winter of 2007, 2008. If you combine all of those years together, all of those winters together, what you finish up with is this. So there is still a bit of a blocking signal, but actually it's just more of an anticyclonic signal, if anything. So a lot of these winters that are just before solar minimum, remember these are the winters that are just preceding solar minimum of these solar cycles, and a lot of them are anticyclonic. There is still a little bit of a blocking signal, but nowhere near, and I do mean nowhere near, the blocking signal that we have with the winters that are 2 years before solar minimum. And when James sent this information through, I was very, very surprised about this, because I would have assumed, I would have thought that the further you get towards solar minimum, the greater your chance of cold and block winters. But certainly from the analogues, it doesn't appear to be the case. It appears that before solar minimum, we're in the best position out of the two scenarios, either being 2 years before solar minimum or being 1 year, or i.e. just before solar minimum. It appears we are in the better of the two to get a cold winter, but not guaranteed. And the difference with these two packages of analogues is that the winters that are 2 years before solar minimum, they are either cold, and there are a lot of them that are cold, and that's why the all years combined chart looks cold. So they're either cold winters, or they are very wet winters, very zonal type winters with a lot of rainfall. Conversely, 1 year before solar minimum, we don't have the split within those years. Most of them are not cold, but many of them are anticyclonic and dry. There's a few there that are wetter, but many of those years are just anticyclonic, dry, and not overly cold. In some cases, quite mild winters. Bear in mind, we do have 95, 96 in the mix there, which is an analogue that's occurring a lot over recent years as well, as is 62, 63, quite interestingly. So we've talked for 55 minutes, another real epic for the 11th and penultimate Winter 2017-18 update. And that just leaves us with one more update to do, and we'll do that 12th and final update for you next week. What we're going to try to do for that one is do something on November, which is always very hard with these winter updates, because we're kind of guessing where we're going to be by the end of November, if you see what I mean. So it's always the hardest part actually of these winter updates. It's always the final update when we try and do something on November, because we're sort of prejudging a bit where November is going to end up. And this November is very tricky as well, because it's not particularly extreme at all. You have a very, very wet first half to November, and you broadly say you're going to have a wetter average month. Or you have a very cold or a very mild first half to November, you can broadly say you're going to finish out colder or milder than average. That's not the case, really, with this November. It's very difficult to pitch exactly where this November is going to finish up, and so therefore it's going to be quite difficult to pitch the analogues. But we are going to try and get something together for you for November for that 12th and final winter update, and then we're going to put it all together 2 weeks today. It's a GavsWeapons.com Winter 2017-18 forecast. We'll get everything together, and we'll see if we can come up with a forecast for winter of 2017-2018. So it's all coming down to the crunch now. Next Saturday we will have the third and final seasonal model roundup. Next Sunday we've got the 12th and final winter update, and then 2 weeks today, Sunday the 3rd of December, it's the winter forecast. And that rounds it all off. Come back later on to have a look at the seasonal models from the ECWF and Meteo France. Those seasonal models covering the winter of 2017-18. You'll see what they are showing this afternoon. This video will be placed on the winter updates page with a written report going over everything we've discussed in the video. But at just gone 57 minutes, that's all for now, and thanks for watching.